Hello everyone. In today's session, we are going to study about the concept of Surds. This topic is beneficial for the students of year 9, year 10 and year 11. So, if you see the screen here, you can see some words like Surds and then integers, whole numbers, natural numbers, rational numbers. In order to understand what is the meaning of surd, you need to understand all these different types of numbers. Surds are not just this sign. There is a condition for the numbers to follow in order to be a surd. So first of all, in our primary grades, we talk about the numbers like counting numbers, which we write like 1, 1, 2, 3, 4, and so on. These all numbers come in the category of natural numbers. So 1, 2, 3, 4, all our counting numbers, we call them natural numbers. Then comes the concept of whole numbers. If I start counting the numbers from 0, including the natural numbers, so 0, then I have 1, then I have 2, then I have 3, and so on. These numbers become whole numbers. Okay, so natural numbers, normal counting numbers starting from 1, so 1, 2, 3, 4, and so on, these are natural numbers. And then whole numbers, if we include 0 with natural numbers, that becomes the whole numbers. Then we learn the third concept or third category of numbers, which are called integers. Integers means when we take our whole numbers, which are like 0, 1, 2, 3, and so on, and we also include their negatives. So -1, -2, -3, -4, and so on. They become integers, or we can also call them negative numbers. Okay, so we covered the definition of what is a natural number, whole number, and integers. Then two more categories come up. One is called rational numbers, and there is one more which is irrational numbers. Irrational numbers. Now, what are they? See, we have already studied about the fractions, and we also know about the decimal numbers. So when we talk about the decimal numbers like 0.1, 0.5, 2.3, 9.7, so these numbers are called rational numbers. Rational numbers basically include the fractions and the decimal numbers. But there is one very important condition on the rational numbers and irrational numbers. Just by saying that a fraction, if it is there, it is a rational number, no, there is a certain condition. So we have to focus more on the rational number and irrational numbers. So let's discuss about it in detail. So we have real numbers, and real numbers have the decimal numbers and fractions. Every kind of fractions are there. Real numbers, they have all kinds of fractions. They can be rational, they can be irrational numbers also. But now, what is the meaning of rational and irrational, and why I am focusing on these two? The reason is because we have to cover the definition of surds, and surds are based on the concept of irrational numbers. So let's discuss these two in detail. So first is rational number. I am going to write here one fraction, which is 1 over 2. And when I write it as a decimal, I can write it like 0.5. This is very important concept, rational numbers and irrational numbers. So I had 1 over 2, it was 0.5. So this is like a terminating decimal number. Terminating decimal number. What is the meaning of terminating decimal number? Means when I divided 1 by 2, I got some numbers after decimal point, but that is finished. It's not keep it, it is not like it keeps going on. Okay, so it is 0.5. Another example, if I take 1 by 4, which is 0.25. So here after decimal, I got two digits, 2/10 and 500, but still it is coming in the category of terminating decimal number. If I take another number as 1 over 8, this is equivalent to 0.125. Again, it is a terminating number. Then another another example I am going to take over here, and that number is 1 over 3. When I take this 1 over 3, and if I try to write it as a decimal number, I got it like 0.333, and it keeps going. It is not terminating. It is not terminating, but it is repeating. The digits after the decimal, that is repeating. There is a possibility that only one digit is repeating, like 0.3333, or there is a possibility it is a number like 0.353535. So it can be anything, but we know it is repeating. So now from here we can see there are two features. One is termination of the decimal part, and then repetition. So that helps us to categorize the numbers as rational numbers and irrational numbers. You need to keep these kind of examples in your mind. Now, what are rational numbers? Rational numbers can be repeating or they can be terminating decimal numbers. So whatever examples I have given here, these all are the rational numbers. So what will be irrational number? Rational numbers can be terminating or repeating. Okay, they can be either terminating or repeating. Any one of the condition, if it is followed, it is the rational number. On the other hand, if I am taking an example of, let's say I am taking an example of square root of 2, you will see this number will come out like 1.414, and it keeps repeat. It is not repeating. Okay, if you see, if I find out its exact value, square root of 2, so it is coming out as 1.414. Let me write this value, 1.414 to 1356, and it keeps going. So what is happening here? I can see two things over here. One, it is non-terminating. It is not ending. So it is non-terminating number, as well as it is non-repeating. The digits after the decimal point, they are not repeating. So if any number follows these two features, non-terminating and non-repeating, both at the same time, we call them surds. Sorry, we call them irrational numbers. Okay, so we call them irrational numbers. Now we understood the concept of real numbers, whole numbers, rational numbers, irrational numbers, integers. Now we get the definition of surds. Now what is the meaning of surds? If you see, there is one letter, this is a pi. It has a value like 3.141143 and so on. So this is also a non-terminating number and non-repeating. So this is also an irrational number. Okay. Now comes the definition of surds. Now what is the meaning of surds? If we take the roots, it can be square root or it can be cube root. It can be any root. Root means I am taking the power like a half, or I am taking a power like 1/3, 1/4. So they become 1 over. So it is a square root or cube root or fourth root and so on. When I write any number over here and I take its square root or cube root like that, and if it generates here an irrational number, then we call it this number A as a surd. Like this whole thing will be called as a surd, not just A, this whole square root or cube root, that will be called as a surd. Clear? So for irrational numbers, is the result of the search. So if you take a square root of a number or you take a cube root of a number and it results into an irrational number means the decimal part, it should be non-repeating and non-terminating. We call it as a surd. Now let's take one more slide over here and let me explain you this all things one more time. So here we have different numbers, like we have 3, we have 0.7, we have pi, 1.3, and there is a dot on the top of this 3. That means this 3 is repeating. Then we have square root 2, minus 1, 3 quarters, square root 9, and e. We have given here the different sets: integers, then rational numbers, then real numbers, and so on. So first of all, here we take this number 3. This 3 is like a whole number, and it's like it comes in the category of integers, because integers means it can have positive whole numbers and it can have the negatives of those whole numbers also. So this 3 will be coming over here. Then we have 0.7. So 0.7 is basically a real number, but in real number we have two categories, rational and one is irrational. So this category is irrational because rational is covered here. So outside will be irrational, and then rational and irrational are covered within the real numbers. So 0.7, because it is terminating number, it is not like non-terminating and non-repeating, so that is not the category of irrational. So this is an this is a rational number. Then we have pi. If you see pi is a non-repeating. Pi has a characteristic of non-repeating. If you check using your calculator, non-repeating and non-terminating, so this will come in this category. Then we have 1.3333, like that. So it is like 1.333. So it is not terminating, but it is repeating. So again, it is a category of rational numbers, because for irrational, both the conditions should be true, non-repeating and non-terminating. Square root 2, as I told, its value is 1.4142, like that. So it is non-terminating, non-repeating. So square root 2 is here. Then we have minus 1. Minus 1 is an integer. It's not a decimal number here. 3 quarters. If you see 3 quarters, it is 0.75, which is the terminating decimal number. So it will be here. Then we have square root 9. And if you use calculator, square root 9 is basically 3. So that is integer. Square root 9 you can write here inside the integers. And then e is a very important constant in mathematics, and its value is like 2.7 and so on, and it is again non-repeating, non-terminating, so e comes here. So we know now the different kinds of numbers, and for a number to be a surd, if we take its square root or cube root or any other root, and if it results into an irrational number, we call it a surd. Okay, now let's go to the next part. So here we have square root 2. Square root 2 is a surd? Yes, square root 2 is a surd. The reason, it is non-terminating and non-repeating. Square root 9, it is not a surd. Square root 5, it is a surd. Now rest of the two questions, I want you to check it by yourself. So what is the definition of surd? A surd is a root of a number, means it can be square root, it can be cube root, or any root that cannot be simplified to a rational number, or we can say that will be an irrational number. So we understand what is the meaning of surds. Now we have the next thing in surds, and that is the rules related to the surds. For example, if we learn about integers in maths, then we learn about how to multiply them, how to divide them, how to add them, how to subtract them. Same is the case of surds. Whenever we learn a new kind of numbers in surds, what we need to understand is the meaning of that definition of that particular kind of number, and then operations on that number. So now we are going to work on the surds. If let's say we have two surds here, One is square root A and another is square root B. And we are multiplying them. See, if only this sign is given, so by default, this is a square root. If this sign is given and here a small 3 is written, that means it is a cube root. For square root, we need not to write any number here. So if it is a square root A and then we are times it by square root B, we can times them both. They both should be like same square root or cube roots or like that. So we can write them under the one square root sign and we can write A times B, or in short, we can write like AB. So this is the law of Surds. Second law is very important, related to the division. And that is, if you have square root of A divided by square root of B, so you can write them under one square root sign and you can write like square root A divided by B. Make sure this rule is applicable only for multiplication and division. If you have square root A plus square root B, you cannot write it equal to square root of A plus B. Similarly, if you have square root A minus square root of B, you cannot write it equal to square root of A minus B. So this is super important thing. Now, because we learned these two rules of the surds, these two laws in the surds, so we will be solving the questions now. So we have square root 3 times square root 2. So there is a multiplication of surds. We can multiply them and we can write under one surd sign, and this is equal to square root of 6. If you can further simplify it, you can simplify. That will be our next thing to discuss. Then we have square root of 1 over 9. So this one can be simplified as square root of 1, square root of 9. You can apply this rule in the reverse order also. Now square root of 1 is 1 and square root of 9 is 3. So my answer is 1/3. Then we have square root of 4x square. Square root of 4x square means I can write it like square root of 4 times square root of x square. So square root of 4 is 2. And if you know the laws of indices, square root means it is the power a half. So I have x square and its power as a half, and then it will be x to the power of 2 times a half, and that is equal to x to the power of 2 times a half means it's 1. So we got our final answer as 2 multiplied by x, which is 2x. Now let's go to our next step, and that is called simplification of surds. Now what is the meaning of simplification? See, when we have a surd, let's say it is 5 over 25. I can simplify it. That means I can divide both of these numbers by 5 and I can get the most simplified answer as 1/5. If I give you anything like 2 plus 3, instead of writing it this way, we can simplify and I can write my answer as 5. Same way, we can simplify the surds also. Sometimes what happens in a surd like square root of 8, they ask us to simplify this surd. Now there is no multiplication sign, there is no division sign. So what can we do? What you need to do, whatever number is given over here, you have to see this number and see, can you write it as a multiplication of two numbers where one number is an which has a proper square root. For example, what are the square numbers? We have 1 square, which is 1, 4, that is the square of 2, then 9, 16, 25, then we have 36, 49, then we have 64, 81, 100, and so on. These all are squared numbers. Why I am focusing on square numbers? Because here we have square root of 8. So square and square root, we are finding a connection. What you need to do when you have to simplify these square roots, these surds, you need to see 8 can be written as a multiple of which of these numbers, the one which is the highest possible number. I can write 8 as 8 times 1, but it doesn't make any difference. Also, I can write 8 as a multiple of 4. So you have to choose a number from these square numbers that you can write 8 as a multiple. So I will be writing 8 as 4 times 2, and then I know this law of multiplication of surds. I can write it square root of 4 times square root of 2. Now square root of 4 is what? It is just a 2, and square root 2 I cannot further simplify because it is a surd. So my answer in the simplified form will be 2 root 2. Clear? Let's go to the next example. Next question is square root of 27. So here I have written all the squared numbers. Square root of 27. So 27 can be written as a multiple of 9. That is the highest possible factor of 27 here in the square numbers. So I will write it 9 times 3. That gives me square root 27. If I write square root of 9 times 3. Then using the law of surds, I can split it as square root 9 times square root 3. Square root 9 is 3 and square root 3 as it is. So this is the answer as a most simplified form of square root 27. You will have to use these kind of simplification while giving your final answer in surds, when you add two surds or when you subtract two surds, or even rationalization. So we will be discussing each of them one by one. Then the next question, let's take it as square root of 50. Now square root of 50, if you see 50 is a multiple of 1 and 50 is a multiple of 25 as well. So square root 50 is equal to square root of 25 times 2. According to the law of surd, I can write it square root 25 times square root of 2, which will give me square root of 25, which is 5, and times by root 2. This multiplication sign you can remove, and you will write the surd part. This is also known as the radicand part. You have to write it always at the end, and the non-surd part, which is without square root, in the beginning. You will never write like square root 2 and 5 here. No, that is not a correct way. Correct way is the non-surd part like 5 here, that you write in the beginning followed by the square root and the number itself. Now let's go to the next one. So this is all about the simplification. Here we have these questions: square root of 24, square root 75, square root 20, square root 48. You have to write all of these numbers in the surd form. So that is the part you can practice. Now let's take another category here. What is it? Multiples of surds. We understand if you have given a number square root 20, how can I write it in a simplified form? But now it's multiples of surds, means there will be written here in this form. So I will say that this number is a multiple a times square root of b. So because of this a, we will say this is a multiple of square root b. Okay, 2 square root b, 3 square root b, 5 square root b, anything. So here we can say this is 6 square root 20. So this is a multiple of square root 20. 6 multiplied by square root 20. Now here 6, I cannot simplify this because it is already in the simplified form. But this square root 20 for sure I can simplify. And again I have to see this square root 20. It can be written as 4 times 5. Why 4 times 5? Because if I write squared numbers, I can see 20 is a multiple of 4. So then I will split it into square root 4 times square root 5. And from there I get it like 2 square root 5. Now the actual question was 6 square root 20, which means 6 multiplied by square root 20. And when I simplified square root 20, I got 2 root 5. So here I have 6 multiplied by 2. These are the non-surd parts. I can multiply them and I can get this answer as 12 square root of 5. Okay. Let's take the second example. 7 square root of 12. So 7 is a non-surd part but square root 12. So I can write this as 7 times square root 12. And then this 12 surd can be written as multiplication of 4 and 3. Why? Because I have to simplify it. Simplify means I need to see, can I write 12 as a multiple of any squared numbers? These are our squared numbers. You need to practice writing them if you have not enough practice. Then you need to split it using the surd law. So this is square root of 4 times square root of 3. Square root of 4 is basically 2. So 7 times 2 times square root 3. And as a final answer, 7 multiplied by 2 is 14 times root 3. So this completes this question. I hope in this lesson what we have covered, you understand it. We have covered the definition of surds. What are real numbers? What are rational numbers and irrational numbers? We have already covered natural numbers, whole numbers, integers. Then in rational and irrational, how to categorize them? What is the meaning of surds? How to differentiate surds from the simple numbers? Then we have discussed about the law of surds. In there, two laws we discussed about the multiplication of two surds and division of two surds. And we know that addition and subtraction doesn't work the same way as multiplication and division. And the last topic which we have covered here, that is the simplification of surds and as well as simplification of the multiples of surds. So you can practice the rest of the questions in this one. Here it is given. In the next session, we will be covering more on the multiplying of surds. We already know the process and we will follow that. But always remember the final answer should be the most simplified answer. If I give you one example from here, you can multiply in different ways. So we have square root 3 times square root 5. We have covered such questions. So it is square root of 15. You just need to see if after multiplication, is there any possibility that you can split them? So you have to split. Otherwise, it's not needed. All right. Thank you. So in this lesson, we have covered the initials, like the basic stuff related to the surd with two laws of surds as well. I will be looking forward to hear from you soon. If you have any question, please comment. Thank you.